Welcome to this video on design patterns. We are going to cover abstract factory design pattern in this particular video. This is part of the playlist design patterns in Java. Whenever we talk about design patterns, we have to consider four things. What is the intent of the design pattern? What kind of problem it solves? What what exactly is the solution, and what are the different consequences which you're going to have. Whenever you're going to learn a design pattern, you have to see the visual aspect of the pattern as well as the implementation aspect. Visually, you should model a design pattern using UML like class diagrams, etc. And implementation wise, you should be able to code in your favorite programming language like C++, Java, etc. In this particular video, I'm going to code it in Java and I'm going to explain to you. I don't want to make a design patterns a very complex topic. It's the most beautiful, interesting topic. So let's get set go. So before this particular video, we discussed about what exactly is a singleton pattern is all about. A singleton pattern is all about having a single object to a class and provide a global point of access to it. So that's where the get instance method. In fact, I have done like 5 different implementations of singleton design pattern in the previous video, and I also said that we can break a design pattern in two different ways, that is singleton. One is using reflection, the other one is using serialization. Now let's get back to this particular video on abstract factory design pattern. Now how am I planning the whole thing? I'm going to use Visual Paradigm. This is an online UML tool for designing the class diagram, and I'm going to use Eclipse to code in Java. So whenever you see this particular thing, like what is the, so abstract factory is part of the creational design pattern. Now all the creational design patterns focus on how the objects are created. Please listen carefully. Creational patterns, that is, there are different creational patterns like singleton, abstract factory, factory method, builder, prototype. Now all these creational patterns focus on how objects are created. Okay, it only talks about creation and initialization of objects. Now let's get into the world of abstract factory design pattern. Now what exactly is the intent of it? You can actually see it provides an interface for creating families of related or dependent objects without specifying the concrete classes. I actually don't understand much when I say this actually. So let us try to break into it. So what is the intent? It's like provide an interface for creating objects or families of related or dependent objects without specifying the concrete class for implementation. If you want to master design pattern, you should be able to remember the intent, because you will remember the intent with the name of the design pattern and the intent of the pattern. Then automatically the visualization actually come into picture. So here we are talking about providing an interface for creating an object without specifying the concrete class for implementation. Okay, now let's start. So let's get into the world of UML. This exactly is the notation for a class. Now let us create a something like a Windows button as a class, and let me drag a bit and add a method called draw. Okay, so I'll come over here. I'll create a new class called Windows button. I'm going to add a method called public void draw, and then say something like system dot out dot println. Windows draw. I was just checking if I'm recording the video or not. Okay. So when we go to this particular place, let us getting creating so Windows button. Now we are trying to see when we say button draw. So when we run this particular program, you see the output Windows draw. Everything looks fine. But what is the intent of the abstract factory design pattern is to provide an interface for creating an object. Now this is not providing the interface for creating an object. Now the line number 7 you see without specifying the concrete class for implementation. So what is Windows button? This is the concrete class. Now guys, you guys have to spend some time in understanding it. It takes some time. It's a journey. It's never a one liner where you understand a design pattern. So abstract factory design pattern says that it provides an interface for creating objects or families of related or dependent objects without specifying the concrete class for implementation. And here we are specifying the concrete class for implementation. So are we implementing the design pattern? No way. We are not implementing the abstract factory design pattern. Then what to do? Let's go one level up. Instead of this class, let us add an interface. Let us add an interface called button. Okay, and have an operation called draw. Now, in today's world, right? Okay, let us add the realization relationship. Okay, now I just wanted to tell you in 2026, not many software engineers or college students or everyone use UML, but in our times, UML was used extensively. Now, I don't feel like using a PowerPoint slide to explain a design pattern when I can use a UML where I can give the best of the visualization. Now, I would rather recommend learn how to draw a class diagram and start understanding the design, in the best possible way. So we are going one level up. We are adding a button as an interface. See, button as an interface where we'll say public void draw. Now the question is in the app.java, instead of button, we will use this. So obviously we have to say implements button. So you need to be pretty good at Java to be able to code and design patterns. If you are new to Java and you want to learn about how to code in Java, I'm already making a playlist on Java full stack development. Today only I had cut a video on how to code in an object oriented way, what is a class, what is an object, what is constructors, etc. Can you please visit that particular video to understand about how to code in classes and objects. At this moment of time we are coming back to abstract factory design pattern. We added an interface and then do it. This looks like a perfect code, using interface and all. Yet we have not implemented abstract factory as a design pattern because in this scenario this particular Windows button is a concrete class and we are using new to create the concrete class. So the line number 7 is provide an interface for creating objects. Yes, we did it, but we are actually specifying the concrete class for implementation. So I would still say that we haven't implemented the abstract factory design pattern. Then what should we go? What we should we go? That's the perfect answer. Now I'm dragging this a bit. and let us come up with a factory as an interface. Okay, in this particular factory, let us create something like create button as a method. For the implementation, since we are talking about Windows, right? I will say Windows factory. Okay, now we can increase this a bit and implement the operation called create button. Okay, and add the realization part. Now I wanted to tell you, if you are able to do this and you are able to explain the logic, right? I can tell you, you have arrived as a designer. That means you are couple of years, away from becoming a Java architect. I can really say that your fluency on the language is on the highest. You are able to visualize and then your code, then you are in a much comfortable position actually. So what did we do? We created an interface called factory. We came up with our own Windows factory as an implementation. So let us go and implement it. So let us create an interface called factory and then say button create factory, create button. Let us create another class called Windows factory which implements the button interface, correct? So I'm sorry, this should be uh, in the factory class. Okay, now Windows factory has to implement the factory interface. See, we make mistakes. Who doesn't make mistakes? Only by correcting we should go forward. So this is how it is. And here I am actually trying to say Windows new Windows button. Hope you are having good time. Now you can actually see that I have come up with a class called Windows Factory, and in the app.java I am slowly moving towards implementing the abstract factory design pattern. So what are we going to do? We're going to say factory is equal to new of Windows factory. Like you have a shoe factory where shoes are manufactured. This is like a Windows factory where Windows related gadgets are widgets are actually manufactured. Now I can instead of saying button is equal to new Windows button, I'm going to use a factory and then call create button. The implementation remain the same. There is absolutely no change in the logic, but we are not using new to create a button object. So remember one thing: the first step of saying whether you have implemented the abstract factory design pattern or not is if you are getting an button object without using new explicitly and you are using a factory. In this case we have used Windows factory, and the factory is the one which is returning the object. So this create button you can actually see is returning the Windows button. Now do you know one thing? You can, so basically what I wanted to tell you is this is all the server piece of code. Now there is something like one of the solid principles called open close principle. That means even though you make changes to the server side, the client side is closed for modification. Open, so you need to be pretty good at this solid design principle. So this is one of the principle called open close principles. Now imagine what has happened is there have been some change of requirements, and we felt that the current implementation of uh, of Windows button is not good enough. Let's say this particular Windows concrete class is an older implementation, and we came up with a Windows button new class with a newer implementation. If you implement using abstract factory design pattern, then what are you going to do? Instead of saying Windows button new, Windows button will say Windows button view. Now come into this particular piece of code. Now this exactly what I say as client's code. Now I'm breathing design patterns here. I'm breathing how a design pattern gets implemented. Now what exactly is the intent of the abstract factory design pattern is to provide an interface to create object without specifying the concrete class for implementation. Now the benefit of abstract factory design pattern is, since you don't have to specify what class needs to be instantiated, at the server side you can actually make the changes and have the fun part of it. Now this is how the abstract factory design pattern is implemented. This is the first level of abstract factory. Now but what exactly is the intent of the abstract factory design pattern? It says that it provides an interface for creating objects or families of related or dependent objects without specifying the concrete class for implementation. Now imagine you have the Windows family. Now if you talk about Java as a JVM, you have if you run Java in a MacBook, then it uses MacBook's JDK and JRE. If you are running Java in Linux, it uses Linux's JDK and JVM and JRE. If you are running Java in Windows, then it is running Windows JDK, JVM and JRE. Now in Java you have a concept of swings, desktop programming. So if you try to create a window in Windows, the same code will look like a Windows window. Whereas if you run the same code in Linux, it looks like a Linux window. And if the same code, if you run it in a Macintosh, it looks like a Macintosh window. So Java internally uses abstract factory design pattern to provide the so-called platform independence. I can say I made a big statement that, but that is true. Now let us go for implementing for more than one factory. But before that, let's increase the number of products also. So you can actually see that, okay, now you have something like scroll bar, and there is another thing called Windows scroll bar. So just try to understand, I can have a scroll bar as one of the family. I can use button, I can use radio button, I can use list. So I have a family of related or dependent products, family of related or dependent projects. So basically what has happened here is I have a scroll bar interface doing this. Okay. Now what am I going to do is I'm going to add one more method here called create scroll bar, and I'm going to implement the create scroll bar. Yeah, now we are talking actually. Now I have a Windows factory. Now similarly you can actually have a Linux factory with the same implementation. So you can actually say create create button and create scroll bar. Now see you can actually see this factory has two implementation. One is the Linux factory, and the other one is the Windows factory. Now let me put the yeah, this is how it is. Now similarly what we can actually do is we can actually come up with Yeah, please give me a couple of more minutes. I'm almost done. So you have Linux button with a draw, and that Linux button is also implementing the button interface. Similarly, we have a Linux scroll bar. So here we have the scroll method. Here we have the scroll method, and here also we have the scroll method. See how beautifully I'm able to explain the design and its implementation using class diagram. So if you master class diagram, you got a lot of benefits actually. Now I think I have come up to a certain stage where I can talk about the abstract factory intent. What exactly abstract factory says? It provides an interface for creating objects or families of related and dependent objects. So I have one Windows family for which I have Windows factory, and I have another family called Linux family which is handled by the Linux factory. So you can actually see that I have two competitor implementations and see how I'm actually merging the thing. Now, if sometimes some product companies what they do is they acquire other competitor products and all. So they have, what happens is, let's say there is a company called Infosys, and then they bought a product. They bought a product. Let's say company Infosys bought a company, and there is a finance product. Okay. Now Infosys itself has a Finacle product. Finacle is having its own customers, and this competitor product which Infosys acquired has got its own customers. Now I have two family of related or dependent products. Now I need to be intelligent enough when I do the mergers and acquisitions, so that I should be able to handle the customers. Yet in the longer run, we wanted to show it as Infosys product rather than showing that as a competitor product. So a lot of design patterns go into implementation in handling these kind of situations. Okay, I'm coming back to this abstract factory design pattern. Currently we have the two families, correct? Now let's go for the implementation. So you have the factory, correct? So I'll say scroll bar, create scroll bar. Similarly I have the Windows factory, right? So we need to define an interface called scroll bar, and here we should say something like public void scroll. So basically I want to compare. So button is an interface. Yes, button interface. Draw is a method. Windows button, Windows draw. Now scroll bar is an interface with scroll as a method. Okay. Now I need to come up with another class called Windows scroll bar. So we will say Windows scroll bar, and here we can actually say something public void scroll. Hmm. Let us create another class called Linux button, which implements the same button interface. Here we can actually say system.out.println Linux draw. Similarly, here I'll say Windows draw new button. So we have a Windows scroll bar. Now let us create a Linux which implements scroll bar interface. Now we will create a Linux scroll bar class which implements the scroll bar interface, and we can actually say system.out.println Linux scroll bar. Got it? Now we have Windows factory. Okay, so we should actually have something like public scroll bar, and then we can say create scroll bar, and then you say return new of Windows scroll bar. Okay, now similarly we should actually create another class called Linux factory which implements the factory interface, correct? And let us remove the to do's over here. So here you can actually say new Linux button, and you have something like new Linux scroll bar. So this guy, why am I having it Linux? Sometimes the only way to get rid of errors is, so we have Linux button. Okay, now what is the error here? Cannot instantiate the type Linux button, because I think accidentally the keyword abstract got added. Now we should go to the Linux factory interface, and you have scroll bar, right? So okay, now I need to understand why this create a method Linux scroll bar. Okay, now look, see, this is part of the game. So we'll say public, and actually the problem gets solved. We should say new Linux scroll bar, especially when you are writing so many classes. uh, okay, now I'm going to copy this here. Yeah, see, do not get panicked, have some patience. Now let us actually see this. Factory is an interface. So factory is an interface, and we are creating the button and creating the scroll bar. Now I have two factories. One is Windows factory, the other one is Linux factory. This is the Windows factory, and this is the Linux factory. Now we have two families of product. One is the Windows family of product. So typically what happens is there is a Linux button, and there is a Linux scroll bar, and there is a Windows button and Windows scroll bar kind of thing. So each has got its own interface called button interface and scroll bar interface. Now let us come back to the main function. Now let's use scanner. Let's say scanner is equal to new scanner of system dot scanner is from the Java util package, so we just have to import it, correct? Now let us say something like while one. I'm trying to create a menu driven interface to call from one family to another family. So we'll say system dot out dot println, say Windows family. Okay, now option number 2, I'll give Linux family, correct? Now option number 3, I will say to exit. Now I'll declare a variable called int choice equal to 0. Now I'll say choice is equal to scanner dot next int. Here I can actually say switch choice. Now here what I'm trying to say is factory is equal to null, correct? Button is equal to null. Scroll bar is equal to null. I'm just defining the interfaces. Now if the choice is 1, that is okay, so I'll say factory is equal to new of Windows factory, and I'm just trying to give a break. Now if the choice is Linux, right? So I'll say new Linux factory. If it is case 3, no, I'll say system dot exit of 1 or whatever it is. Now after the switch case, right, I'll actually say button is equal to factory dot create button, and scroll bar is equal to factory dot create scroll bar. Now when I say system dot when I say button dot draw or button dot scroll, sorry, and then I'll say scroll bar scroll. Now look at this beautiful piece of code. I really love, inheritance, method overriding, polymorphism, dynamic binding, God knows what it is. Now at the time of compile time, right, at the time of compile time, correct, um, one second, I think I made a mistake. Okay, so I can actually say button is equal to like this. Okay, similarly I can say scroll bar. Yeah, I think this piece of code is a redundant code. I can just take it out. So when I run this particular program, you see new Java application, looks like I still have some error to fix. Why? And say while true, because it while as a condition expects a boolean value. Now the code is running. Now if I say 1, right, you see the output is Windows scroll and Windows draw new button. So if I choose Windows factory, this piece of code is getting executed for Windows. Now similarly if I select Lex 2, then you see Linux scroll bar or Linux button, etc. So I have integrated two families of products, and I've written a generic code as far as the client side is concerned. So if you're trying to say, if you say I want Windows, this code will work for Windows. If you say I want Linux, this code will work for Linux. Now if tomorrow if Elon Musk comes up with his own JDK and his own JVM and his own operating system and all, it's easy to extend this particular code base to incorporate Macintosh or incorporate Elon Musk OS, whatever it is, if it is coming in future. So this particular code is not only secure for today, but it is actually secured for tomorrow. Now, one more thing which I'm really bothered is you should not, misuse design patterns. So if there is no multiple families of products, right, and you should just go for the simpler factory implementation, and you should go about it, correct. So let us go back to the intent of this particular design pattern is to provide an interface for creating families of related or dependent objects without specifying the concrete class for implementation. Now it is a question time. Can you please provide a similar example where abstract factory can be used, and can you please put that in the comment area? Do you like this particular video on how a design pattern should be, what is abstract factory design pattern and what exactly it promises? I really love it. So thank you very much for attending this particular video. In the next video we will discuss about the factory method design pattern. Okay, thank you very much. Bye bye. Have a good day.